One other basic concept that I want you to be familiar with is just sort of a brief introduction, if you will, to probability. When we talk about the probability of an event, which notice the statistical value there is p, so whenever we see p, we know we are talking probability. So in this case, the probability of an event equals the number of successes over the number of possible outcomes. One of the big things I want you to note, and I will violate this multiple times, you will violate it, you will see it violated multiple times, but is this idea that you cannot obtain the probability of a single event. Rather, all you can do is tell its frequency. In order to calculate probability, we need a series of events. It's the idea of in the long run. This becomes an important concept. So let me give you an example. If I were to take a coin out of my pocket and tell you to call heads or tails, and you pick one, okay? Then I would ask you, what's the probability that you're going to be right? Most of you would say it's 50-50, right? You've got a 50% chance of being correct. The question I have for you is what it really is the probability that I'm going to get heads. Now some of you are saying it's 50-50, but that's not entirely true. What we do know when it comes to probability is that if I flip the coin long enough, and numerous times, eventually, assuming it's not a coin, a trick coin, or weighted incorrectly, that it's a normal coin, assuming that, I am going to get, on average, the same number of heads and the same number of tails. Okay, that's what we know. But from any single flip, I don't know whether it's going to be heads or tails. We say it's 50-50, but that's not entirely true. It's only 50-50 in the long run. I could theoretically flip the coin and get 5 heads in a row, then 3 tails, and then 5 heads, and then 6 tails. We don't know what that actual probability of a single event is. I just know in the long run, if I flip the coin enough, approximately heads and tails will equal out, okay, over time. And if I do it long enough, I will get an equal number of heads and tails if I keep going long enough. Okay, so the probability of independent events we tend to call or use the term and when we do those we will multiply, and I'll give you an example here in a second. On the other hand, when we talk about an or something happening, we simply add those. So let me give you an example. Let's say we have a die, and we're going to roll this die, let's say 2 times. And I want to know what is the probability of getting a 1 the first time and a 2 the second time. So in this case, I want a 1 the first time, and then I want a 2. Okay, so let's figure this out. Probability, we go back to the top, number of successes over the number of possible outcomes. If on the first roll of that die, I need to roll a 1, what is the probability of success? Well, on any die, there's only one 1, so I can get a 1 time out of a total of 6, right? Because there are numbers 1 through 6 on the die. Now, I also want to roll that same die a second time, and this time I want to get a 2. How many chances of success do I have at rolling a 2? It's still 1. Out of the possible outcomes is still 6. Now, let's look at the language I'm using here. I want to roll a 1 and then roll a 2. What do? I multiply. So 1 times 1 is 1. 6 times 6 is 36. So in the long run, if I were to roll these dice 2 times each set, on average, or in the long run, I'm going to end up with a 1 out of 36 chance of rolling a 1 and then rolling a 2. Okay, does that make sense? Okay, let's look at this a little bit differently. And this time, I'm going to ask, what is the probability of rolling a 1 or a 2? Okay, so in this case, I'm still looking at 1 out of 6 chances for a 1. I'm also looking at, again, 1 out of 6 chances for the 2. But this case, I'm just going to roll, let's say, 1 time. And I want to know on that single roll, what is the probability of rolling a 1 or a 2 on a single roll. Well, I'm using an or here, right? So in this case, I'm going to add. So what's 1 plus 1 is 2. Doesn't look much like a 2. Okay? And when we add fractions, in case you don't remember, it's still out of 6. So in this case, it's 2 out of 6, which gives me a 1 out of 3 chance. Okay? So if I roll a single die one time, and I need a 1 or a 2, I can hit that 2 out of 6 times, or 1 out of 3. And if you think about this sort of intuitively, what some of you might have done in your head is, I know I need a 1 or a 2, that's 2 numbers out of the 6. You sort of may have done this in your head and jumped to the end, where you end up with, I've got a 33% chance, if you will, a 1 out of 3 chance in the long run of rolling a 1 or a 2.